y of 0.2. Here we use Taylor series method to find approximate solution of the ordinary differential equation y prime is equal to 3x plus y over 2 at x is equal to 0.1 and at x is equal to 0.2. Now we start the solution. Given that y prime is equal to 3x plus y over 2 and y of 0 is equal to 1. This implies that x naught is equal to 0, y naught is equal to 1. Similarly, to find the Taylor series solution, we also take derivatives, successive derivatives. So y double prime is equal to 3 plus y prime over 2. Y triple prime is equal to y double prime over 2. And y fourth derivative is equal to y triple prime over 2. For better approximation, we have to take more derivatives and so on. At x is equal to 0. Now we find the values of these derivatives at x is equal to 0. Y prime naught here, y prime naught is equal to 3x naught plus y naught over 2, which is equal to 3 into 0 plus 1 over 2 is equal to 1 by 2. Y double prime naught is equal to 3 plus y prime over 2, which is equal to 3 plus y prime is equal to 1 by 2, 0.5 over 2, which is equal to 3.25. Similarly, y triple prime naught is equal to here y double prime naught over 2, which is equal to 3.25 over 2. So we have 1.625 and y fourth derivative naught is equal to y triple prime naught over 2, which is equal to 1.625 over 2, which is equal to 0.8125. Since first we find y of 0.1 and here we given x naught is equal to 0, so we have to choose step size. Choose h is equal to 0.1 as a step size. Then x1 becomes x naught plus h is equal to 0 plus 0.1 is equal to 0.1. By Taylor series, y of x1 is equal to y of x naught plus h is equal to y naught. It means y of x naught plus h y prime naught plus h square over 2 factorial y double prime naught plus h raised to power 3 over 3 factorial y triple prime naught plus h raised to power 4 over 4 factorial y fourth derivative naught plus so on. By putting the values of h and y prime naught, y double prime naught, y triple prime naught and so on, we obtain y of 0.1 is equal to y naught is equal to 1 plus h 0.1, y prime naught is equal to 0.5 plus h square 0.1 square over 2 factorial is equal to 2 and y double prime naught is equal to 3.25 plus 0.1 cube into y triple prime naught is equal to 1.625 plus 0.1 raised to power 4 over 4 factorial 24 and fourth derivative of y at x is equal to 0.8125 plus so on. After simplifying this expression by using calculator, we obtain y of 0.1 is equal to 1.0665. Now we find second iteration for x2. So we have y prime 1. y1 y of 0.1 is equal to y1. So therefore x1 here x1 is equal to 0.1. y prime 1 will becomes from this differential equation y prime 1 becomes 3x1 plus y1 over 2. Putting the values of x1 and y1, we obtain 3 into 0.1 plus 1.0665 over 2. We have y prime 1 is equal to 0.8333. Y double prime 1 is equal to 3 plus y prime 1 over 2, which is equal to 3 plus 0.8333 over 2, which is equal to 3.4166. Y third derivative 1 is equal to y1 double prime over 2, which is equal to 3.4166 over 2. It becomes 1.7083. And y fourth derivative 1 is equal to y triple prime 1 over 2 is equal to 1.7083 over 2. It becomes 0.8542. Now we find y of x2. Y of x2 is equal to y of x1 plus h. By using Taylor series, we have y1, it means y of x1 plus h y prime 1 plus h square over 2 factorial y double prime 1 plus h cube over 3 factorial y triple prime 1 plus h raised to power 4 over 4 factorial y fourth derivative 1 plus so on. By putting the values of h and y ones, we obtain y1 is equal to 1.0665 plus h is equal to 0.1 and y prime 1 is equal to 0.8333 plus 0.1 scale over 2 factorial is equal to 2 and y double prime 1 is equal to 3.4166 plus 0.1 cube over 3 factorial is equal to 6 and y triple prime 1 is equal to 1.7083 and plus 0.1 raised to power 4 over 4 factorial is equal to 24 and y fourth derivative is equal to 0.8542 plus so on. After simplifying this expression, we obtain y of x2 is equal to 0.2. So we have y of 0.2 is equal to 1.1672. 1.1672. These are the required approximate values of y at 0.1 and 0.2 at x by using Taylor series. Here we use Taylor series method 3 times to solve this differential equation numerically. Now start the solution. Given that y prime is equal to xy plus y square and y of 0 is equal to 1. This implies that x naught is equal to 0 and y naught is equal to 1. Now we take the derivative of y double prime is equal to, here we use product rule, x as it is, derivative of y plus derivative of x is equal to 1 and y as it is, and derivative of y square is equal to 2y y prime. Now taking taking derivative with respect to x, y triple prime is equal to, here also we use product rule, x derivative of y prime y double prime plus derivative of x is equal to 1 and y prime as it is, derivative of this y is y prime, and here we also use product rule, 2y y double prime plus 2y prime y prime. Combining same terms, we have x y double prime plus 2y prime plus 2y y double prime plus 2y prime square. Now we can take fourth derivative, y fourth derivative is equal to x y triple prime plus derivative of x is equal to 1 y double prime plus 2 constant and derivative of y prime y double prime plus, here we use product rule, 2y y triple prime plus 2y prime y double prime, and here we use power rule, 4y prime y double prime. After combining same terms, we obtain fourth derivative of y is xy triple prime plus 2y prime and y prime is equal to 3y double prime. 2y triple prime, 2y prime y double prime to 4y prime y double prime will become 6y prime y double prime, and this term 2y y triple prime. Now we find the values of all these derivatives at x naught is equal to 0. Y prime naught is equal to x naught y naught plus y naught square. We know that x naught is equal to 0, so this term becomes 0, and y naught is equal to 1 and square of 1 is equal to 1, so we have y prime naught is equal to 1. Now again y double prime naught is equal to x naught y prime naught plus y naught plus 2y naught y prime naught. X naught is equal to 0, this term will be vanished, and y naught is equal to 1, 1 multiplied by 1 multiplied by 2, which is equal to 0 plus 1 plus 2 is equal to 3. Y triple prime naught is equal to y triple prime x naught y double prime naught plus 2 y prime naught plus 2 y naught y double prime naught plus 2 y prime naught square. After putting these values, the values of y prime x naught prime y naught double prime, we obtain y triple prime naught is equal to 10. Y fourth derivative naught is equal to x naught y triple prime naught plus 3y double prime naught plus 6y y prime naught y double prime naught, or plus 2y naught triple prime. After simplifying this expression, we obtain y fourth derivative at x naught is equal to 47. Take step size, choose h is equal to 0.1. Therefore, y of x, this implies that x1 is equal to x naught plus h is equal to 0 plus 0.1 is equal to 0.1. So we have y of 0.1 is equal to y naught is equal to 1 plus h 0.1, y prime naught is also equal to 1 plus h square 0.1 square over 2 factorial is equal to 2, and y double prime naught is equal to 3 plus 0.1 cube over 3 factorial is equal to 6, and y triple prime naught is equal to 10 plus 0.1 raised to power 4 over 24 and multiply by y fourth derivative is 47. After simplifying this expression, we obtain y of 0.1 is equal to 1.1169. Similarly, for now here x1 is equal to 0.1 and y1 is equal to 1.1169. Now we find the values of y prime 1, y prime, y double prime, y triple prime, and fourth derivative of y at x1 or x is equal to 0.1. Since we know that y prime is equal to xy plus y square, therefore y prime 1 becomes x1 y1 square. Putting the values of x1 and y1, we obtained 0.1 into 1.1169 plus 1.1169 square. We obtain derivative of y double prime 1 is equal to 1.3592. Similarly, y double prime 1 becomes, we know that y double prime is x y prime plus y plus 2y y prime at y double prime 1 will becomes x1 y1 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 y prime 1. By putting these values we obtain x1 is equal to 0.1, y prime 1 is equal to 1.3592 plus y1 1.1169 and plus 2 into y1 1.11692 69 and y prime 1 is equal to 1.3592. After simplifying this expression we obtain y double prime 1 is equal to 4.2890. Similarly y triple prime 1, we know that y triple prime is equal to xy double prime plus 2y prime plus 2y y double prime plus 2y prime square, and at x is equal to 1 it will become x1 y1 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 y1. Putting these values we obtain x1 is equal to 0.1, y1 double prime is equal to 4.2890 plus 2 y1 prime equal to 1.3592 plus 2 into y1 is equal to 1.1169 and y1 double prime is equal to 4.2890 plus 2 into y1 prime square 1.3592 square. After simplifying this expression we have y triple prime at x is equal to 1 is 16.4229. Similarly y fourth derivative 1 is equal to 86.1724. Now we find y of 0.2, it will become x2. Y of 0.2, since we have x1 is equal to 0.1, y1 is equal to 1.1169, x2 becomes x1 plus h is equal to 0.1 plus 0.1 is equal to 0.2, and x2 can be written as x1 plus y of x2 is equal to y of x1 plus, so Taylor formula becomes y1 plus h y prime 1 plus h square over 2 factorial y double prime 1 plus h की power 3 over 3 factorial y triple prime 1 plus h raised to power 4 over 4 factorial y fourth derivative of 1 plus so on. After putting the values of h and y1 prime, y1 double prime, y1 triple prime and y1 fourth derivative, we obtain y of 0.2 is equal to 1.2774. Similarly, we can find y of 0.3 here. Now x2 is equal to 0.2 and y2 is equal to 1.12774 and x3 will becomes x2 plus h becomes 0.3. Bismillahirrahmanirrahim. Dear student, today we solve ordinary differential equation. Today we solve ordinary differential equation by using Maclaurin series method. Here we have a question. By using first 4 terms of Maclaurin series, find y at x is equal to 0.1 is 0.1, 0.6. It means we start from 0.1, we take the value of x, values of x 0.1, 0.2, 0.3, 0.4, 0.5 and 0.6. Given that 2y prime is equal to 1 plus x into y square, y of 0 is equal to 1. This is an initial condition for the differential equation. Compare the values with the exact solution. तो हमने इन वैल्यूज को एग्जैक्ट सॉल्यूशन के साथ कंपेयर भी करना है. तो हमारे पास ये गिवन है कि 0.1 ब्रैकेट में लिखा हुआ है बुक में और इसमें 0.6 भी लिखा हुआ है. तो इसका मतलब ये है कि हमने 0.1 x की वैल्यू 0.1 से 0.6 तक लेके जानी है और उसमें जो स्टेप साइज लेना है वो 0.1 लेना है. Now we start the solution. Since given that 2y prime is equal to 1 plus x into y square, y of 0 is equal to 1. This condition means this implies that x naught is equal to 0 and y naught is equal to 1. Since we find 4 terms of Maclaurin series, therefore we have to take 2 more derivatives of this differential equations. Differentiating with respect to x, we have 2y double prime. Here we use product rule. 1 plus x as it is, derivative of y square 2y y prime, plus derivative of 1 plus x is equal to 1. Derivative of 1 0, derivative of x equal to 1. So we have only y square. Now again taking derivative with respect to x, 2y triple prime equal to, here we use a product rule 3 times, 3 terms, on 3 terms. 1 plus x into 2y as it is, derivative of y prime, y double prime, plus 1 plus x as it is, derivative of 2y prime and y prime taken as it is, plus derivative of 1 plus x is equal to 1, so we have 2y y prime, and plus derivative of y square, we use product rule, power rule, 2y, and further derivative of y is y prime. So we have 2y double prime triple prime is equal to 2 into 1 plus x y double prime plus 2 into 1 plus x y prime square, plus these two terms are same, so can be added 4y y prime. Now we find the values of 3 derivatives, y prime, y double prime and y triple prime at x is equal to 0. At x is equal to 0, y prime becomes y prime naught is equal to 1 by 2, the multiplication 2 converted into division, and we have 1 plus x naught into y naught square. Putting the values of x naught and y naught, x naught is equal to 0 and y naught is equal to 1. So we have 1 by 2 into 1 plus 0 multiplied by 1 square, which is equal to 1 by 2. Y double prime naught becomes, here we find, from here we find the value of y prime, double prime naught, which is equal to 1 by 2 into 1 plus x naught to y naught y prime naught plus y naught scale. Putting the values, we obtain 1 by 2 into 1 plus x naught, 1 plus 0 is equal to 1, 2 y naught is equal to 1 and y prime naught is equal to 1 by 2, 2 multiplied by 1 multiplied by 1 by 2 is also equal to 1, and y naught square plus 1, which is equal to 1. 1 plus 1 equal to 2 and 2 multiplied by 1 by 2 is equal to 1. Similarly, we can find the value of y triple prime naught is equal to 1 by 2 into 2 into 1 plus x naught into y naught y double prime naught plus 2 into 1 plus x naught y prime naught square plus 4 y naught y prime naught. After putting the values of y naught, y double prime naught and y prime naught and y double prime naught, we obtain y of x is equal to y naught plus x y prime naught plus x square over 2 factorial y double prime naught plus x raised to power 3 over 3 factorial y triple prime naught plus so on. Putting the values of y naught, y prime naught, we know that y naught is equal to 1. So y of x is equal to 1 plus x. Y prime naught is equal to 1 by 2. 1 by 2 plus x square over 2. Y double prime naught is equal to 1 plus x raised to power 3 over 6. And y triple prime naught is equal to 9 by 4 plus so on. So we have y of x is equal to 1 plus x by 2 plus x square by 2 plus 3x cube over 8 plus so on. Now we can find y of 0.1, which is equal to 1 plus 0.1 over 2 plus 0.1 का square over 2 plus 3 into 0.1 का cube over 8 plus 1. After simplifying, we obtain 1.0554. Similarly, y of 0.2 equal to 1 plus 0.2 over 2 plus 0.2 square over 2 plus 3 multiplied by 0.2 cube over 8 plus so on, which is equal to 1.1237. Y of 0.3 is equal to 1 plus 0.3 over 2 plus 0.3 square over 2 plus 3 into 0.3 cube over 8 plus so on, which is equal to 1.2085. Similarly, we can find y of 0.4, y of 0.6. Similarly, y of 0.4 is equal to 1.3197. Y of 0.5 is equal to 1.4479 plus y of 0.6 is equal to 1.615. These are the approximate values of y at x is equal to 0.1, 0.2, 0.3, 0.4, 0.5 and 0.6. Now we find exact solution. Since this differential equation is separable, we can see that clearly. So we have 2 dy over dx is equal to 1 plus x into y square. It can be written as 2y raised to power minus 2 dy is equal to 1 plus x into dx. Integrating on both sides, we have 2 into y raised to power minus 1 over minus 1 is equal to x plus x square over 2 plus c, constant of integration, can be written as minus 2 over y is equal to x plus x square over 2 plus c. By using initial condition at x is equal to 0, y is equal to 1, we obtain minus 2 over 1 is equal to 0 plus c. So we have minus 2 is equal to c. By putting the values of c in the general solution, in this solution we have minus 2 over y is equal to x plus x square over 2 minus 2. It can be written as 2 over y is equal to 2x plus x square minus 4 over 2. Taking reciprocal, y over minus 2 is equal to 2 over 2x plus x square minus 4. So y of x is equal to minus 4 over 2x plus x square minus 4. This is an exact solution for this differential equation. Now we find y of 0.1, which is equal to 4 over 2 into 0.1 plus 0.1 square minus 4. After simplifying this, we obtain 1.0554. We can see that the exact solution of y at x is equal to 0.1 is 1.0554, and approximate solution by using Maclaurin series, 4 terms of Maclaurin series, we obtain y of 0.1 is equal to 1.0554. It means this approximate solution is correct to 4 decimal places. Similarly, y of 0.2, 4 over 2 into 0.2 plus 0.2 square minus 4. Here we have also minus 4. After simplifying this by using calculator, we have 1.1236. By using 4 terms of Maclaurin series, we obtain y of 0.2 is equal to 1.1237, and here we have 1.1236. These are two solutions are also very nearly equal. Similarly, we obtain y of 0.3, y of 0.4, y of 0.5 and y of 0.6. Bismillahirrahmanirrahim. Today we discuss the question: find the first 6 term of power series solution of y prime is equal to sin x plus y square, which passes through the point 0, 1. Since given that y prime is equal to sin x plus y square and the given point 0, 1, this implies that x naught is equal to 0 and y naught is equal to 1. Since we have to find the first 6 terms, therefore first we find five derivatives, like y double prime is equal to cos x plus 2y y prime. Again taking derivative with respect to x, y triple prime is equal to minus sin x plus 2y prime plus 2y y. It can be written as minus sin x plus 2y prime square plus 2y y double prime. Again taking derivative with respect to x, y fourth derivative is equal to minus cos x plus 4y prime y double prime plus 2y prime y double prime plus 2y y triple prime. Adding these same two quantities, y fourth derivative becomes minus cos x plus 6y prime y double prime plus 2y y triple prime. Now again taking derivative with respect to x, y fifth derivative will becomes sin x plus 6y double prime plus 6y prime y triple prime. By using product rule on these two terms, derivative of y prime y double prime taking as it is plus 6y prime taken as it is, and derivative of y double prime is y triple prime. Similarly, by using product rule on these two terms, we have 2y prime y triple prime plus 2y y fourth derivative. Now we have fifth derivative sin x plus 6y double prime square. These two quantities are the same, so can be added 8y prime y triple prime or plus 2y y fourth derivative. Now we find the values of all derivatives at x naught is equal to 0 or x naught equal to 0 and y naught is equal to 1. Since y prime is equal to sin x plus y square, therefore y prime naught becomes sin x naught plus y naught square. Putting the values of x naught and y naught, we have sin 0 plus 1 square, which is equal to 1. Similarly, y double prime naught we obtain cos x naught plus 2y naught y prime naught. Putting the values of x naught and y prime naught, we have cos 0 plus 2 y naught is equal to 1 and y prime naught is also is equal to 1. Cos, we know that cos of 0 is equal to 1 and 2 multiply 1 is 2 and 1 plus 2 is equal to 3. Y triple prime naught is becomes the expression for y triple prime is minus sin x 2 y naught y prime square plus 2 y double prime. So we have minus sin x naught plus 2 y naught prime square plus 2 y naught y double prime naught. Putting all these values, we know that sin x naught equal to 0 and sin 0 is 0 and plus 2 y prime is equal to 1, so square of 1 is also 1, plus 2 y naught is equal to 1 and y double prime naught is equal to 3. After simplifying this expression, we have y triple prime naught is equal to 3 2s are 6 plus 2 is equal to 8. Now we use fourth derivative formula. Y fourth derivative naught is equal to y fourth derivative is minus cos x plus 6y y double prime plus 2y y triple prime. So we have minus cos x naught plus 6y prime naught y double prime naught plus 2y naught y triple prime naught. Putting all these values, we know that cos of x naught equal to 0 and cos of 0 is equal to 1 plus 6 y prime naught is equal to 1 and y double prime naught is equal to 3 plus 2 y naught is equal to 1 and y triple prime naught is equal to 8. So we have minus 1 plus 18 plus 16 which is equal to 33. Now last derivative, fifth derivative of at point x naught, y fifth derivative of naught is equal to sin x naught plus 6 y double prime naught scale plus 8 y prime naught y triple prime naught plus 2 y naught y fourth derivative of naught. Y fourth derivative of sin x naught plus 6y and double prime naught and 8y prime naught plus y triple prime naught plus 2y naught y fourth derivative of naught. Since we know that all these values, we have 6y double prime naught equal to 3, square of 3 is equal to 9, 8y prime naught is equal to 1, y triple prime naught is equal to 8, 2y naught is equal to 1 and y fourth derivative is equal to 33. After simplifying these expressions, we have y fifth derivative at point x naught is 184. We use Maclaurin series expansion. Y of x is equal to y naught plus x phi prime naught plus x square over 2 factorial y double prime naught plus x की power 3 over 3 factorial y triple prime naught plus x की power 4 over 4 factorial y fourth derivative of x naught y naught plus x raised to power 5 over 5 factorial y fifth derivative naught plus so on. After putting these values, we obtain y of x is equal to y naught is equal to 1 plus x y prime naught is also equal to 1 plus x square over 2 factorial is equal to 2 and y double prime naught is equal to 3 plus x raised to power 3 over 3 factorial 6 and y triple prime is equal to 8 plus x raised to power 4 over 4 factorial is equal to 24 and we know that 33 and x की power 5 over 5 factorial is 120 and value of fifth derivative at point x naught is 184 plus so on. After simplifying this expression, we have y of x is equal to 1 plus x plus 3x square over 2 plus 4x cube over 3 plus 11x की पावर 4 over 8 and plus